Hello, everyone, and welcome back to Earth Science. We are starting a new quarter, we are starting a new module, and we are starting our discussion with geomorphic processes. So, we will be discussing what are the changes that the Earth undergoes on the surface that we can readily observe and underneath the Earth's surface. So for our learning objectives, we will describe how rocks undergo weathering, explain why the Earth's interior is hot, describe what happens after magma is formed, describe the changes in mineral components and texture of rocks due to changes in pressure and temperature, which is called metamorphism, describe how rocks behave under different types of stress, such as compression, pulling apart, and shearing. So you will notice from the learning objectives that we are deep into Earth science. So the last few modules have been discussing a lot about Earth's resources, very basic, general, although important topics. Though this time we will be focusing on hard Earth science. So let's go ahead and start. Okay, so we all know that our planet continuously changes. There are different processes on Earth which changes our landscape, but even the structures that we build are not immune to those changes. That's why there are several organizations, namely UNESCO, which tries to preserve these types of structures. But remember, these important structures, like the one you see on your screen, are from materials of the Earth, meaning the changes that the Earth itself undergoes are going to happen to the structures that we build. So a good example is this very beautiful Angkor Wat temple. However, as you can see, it's now in different forms of disrepair due to different geomorphic agents. So humans continuously using the temple, climate, plants, etc., will contribute to the changes of structures like this. Another example of the changes a certain structure could go through is this. This is a picture of the biggest Buddha on Earth, located in Sichuan, a province of China. So you can see it's very big. However, it's also not immune to geomorphic agents. Even the famous Statue of Liberty is not immune to geomorphic agents. When France built the Statue of Liberty in New York to represent friendship between the two countries. It used to be copper, like color copper, but now due to geomorphic processes, it's now color blue. There. So that's just one example of geomorphic processes. So that's just some of the reasons that why we should study geomorphic processes, because there are certain structures that we have to protect, and also to further understand how these changes could be manifesting in our world around us. Okay, so to give you a formal example or a definition, geomorphic processes are the physical processes which create and modify, so highlight on those two terms, create and modify landforms on the surface of the Earth. It can either be endogenous or also called endogenic versus exogenous or exogenic processes. So as you can denote or as you can infer from the words here, we have two types of geomorphic processes. So you have endogenous, which means it happens underneath the surface of the Earth. So plate tectonics, magma formation are part of the endogenous process, and then exogenous process are the ones that are happening here on the surface. So you will learn that weathering, erosion, oxidation, and so forth are part of the exogenous process. So I would like to highlight that these two are always connected because they create and modify landforms or relief. So when we say landforms, like the land masses. So as you know, movements of plate tectonics and magma creates our landscape, and that's part of the endogenous process. Then those landscapes can be further changed because of weather, erosion, so they could also modify through exogenous processes. Okay, so more details on each of those two types of geomorphic geomorphic processes later. Then it involves the rock cycle. So you already know that we have discussed about the rock cycles, how rocks are always constantly changing because rock cycle is just one part of the large geomorphic processes. So we'll move on to discuss these two types in depth. So first, we have your exogenous processes or gradational. So looking at how slow exogenous processes is in terms of the human lifespan, since they are very slow, that's why they are also called gradational processes. So exogenous processes involve degradation and aggradation. So when we say degradation, that's the breaking of materials of the parent material. And then later on, once it has been broken into smaller pieces, they may later aggregate. So it's also like the rock cycle. If you can recall, sedimentary rocks are from other types of rocks, so it can further degrade and later on will clump and cement to form a new type of rock. So that part of the rock cycle is actually an exogenous process. So they, as mentioned earlier, they modify relief or they modify your landscape. So in this part of the lecture, relief is synonymous to landscape. So they modify landscape due to degradation and aggradation. When we are talking about exogenous processes, there are different things that could happen, or it can have a continuum of processes. So first, you may have weathering. So when we say weathering, as I said, the parent material breaks into smaller pieces. Mass wasting is the fast and often large-scale movement of those weathered materials. So you may know or call them as landslide, but in formal terms, they are called mass wasting. Okay, so not necessarily that large of a scale, but as you can imagine, like even small cascades of weathered materials going down the slope and so forth, that's called mass wasting. So erosion is the small kind of mass wasting that is common in our everyday life. Okay, so mass wasting is a large-scale movement of weathered materials, while erosion is just the normal movement of materials or weathered materials. Then finally, the materials after being weathered may further be transported by other geomorphic agents before finally being deposited into one location. So all of this may not necessarily happen. Sometimes the material just weathers and then stays there and become the soil. Not necessarily it will go through the mass wasting, erosion, transportation, and so forth. Or it could stop in erosion, then that's it. Or transportation, and that's it. But this continuum may continuously happen as well. Okay, so again, just to clarify, all these steps are not necessarily happening in just one certain location. Some of the steps may happen, or just one of the steps may happen. Okay, so these processes are carried through by geomorphic agents. So when we say geomorphic agents, these are the factors which causes the weathering or the continuous exogenous process. So as you can denote from the pictures, you have your water, ice, wind, plant life, and of course, human beings are geomorphic agents. Okay, so we have mentioned earlier that when it comes to exogenous process, there are two parts. You have your degradation process, also called denudation, and you will see that we have divided the continuum process based on these two parts. So you have your degradation process, and that involves the weathering, mass erosion, mass wasting, erosion, and transportation. Then finally, for aggradation, here you have the deposition. So when we say deposition, again, this is the final clumping or creation of, I had to pause there. Okay. Clumping of new material. Okay, so the deposition or the clumping of new materials into rocks or new landscapes could be fluvial, so glacial or coastal in nature. Okay, next. Okay, So I would like you to observe this rock. So you can see that it's a big boulder. However, you can observe that there is a straight split in the middle. And you might wonder why or how did this rock break? I mean, how did this boulder break? It looks like it's been cut by some sort of supernatural being, cleanly struck in the middle. But there is a scientific explanation behind this. Right. Then we also have these types of rock. So you will see that they are the same type of rock, and they are for some reason in a landscape, and they are on top of one another. So how did they end up there, and did anybody do that on purpose? Then we also have, okay, so there is again an explanation for this, and one good factor of these types of breakage of rocks and boulders is water. So as you know, water is the universal solvent because as time goes by, water eventually breaks down every type of landform. So for example, you have a type of rock, and as all rocks, they are not perfect. There will be some parts of the rock which will have little cracks, crevices, joints in them, or little holes that the water could go into. So the water will collect into the rock crack. So we'll call it a rock crack. Then, if there are changes in seasons, in that location, water will freeze. So from during the summer, or during the spring and summer, water may eventually end up into the rock due to the rain, but coming fall and winter, it will start freezing. And the good thing about water, or the fun thing about water, is it expands when it freezes. So as you can imagine, you have water in your crack, and then it starts to expand. Once it freezes, it will start cracking the rock itself. Then it will thaw. Okay, so the ice will melt eventually after winter, and then more water will get in due to the changes in season, and then it will be a repetitive cycle of water, ice, continuously cracking the rock, and eventually, due to too much of the crack, the rock itself will split. So let's go back to the picture here. So we can imagine that here in the middle, there used to be a small crack here, but eventually, due to the water always getting into the crack, expanding, going into the crack and expanding repetitively, the rock itself broke apart. So this clean breakage here is a clue how that water is responsible, because it has smooth surfaces. So here as well, you look at this landscape here, and it's the same type of material because they used to be one boulder, and there was water in its cracks, and then because of continuous ice and rain, changes in seasons, eventually they broke apart into different pieces of rock. So knowing geomorphic agents, or how water is responsible in changing our landscape, would give you answers of how much our world has changed already. Okay, so that's just one example of how water is a geomorphic agent. Okay, so we'll go back to the parts of exogenous process. Again, we have your weathering, mass wasting, and then your erosion. So when I would like to highlight, then again, mass wasting is the large scale movement of your weathered materials, then erosion is the small scale movement. Okay, so together these processes are responsible for denudation of the Earth's surface. Okay, so we'll stop here, I think, because the video is quite long now. But in the next video, we will be continuing with weathering.